Hello everyone, welcome to Cypher Page, and today we are going to solve Leetcode number 1406, that is Stone Game 3. It is a hard question, but we will make it easy. Okay. So Alice and Bob continue the game with the piles of stones. There are several stones arranged in a row, and each stones has an associated weight with which is an integer. Okay, so what we have to do, they are just playing the games and Alice will start the game first. We have just take the stones, and the twist in this question is that you can select one stone at a time, two stone at a time, or three stone at a time. Okay, so collectively you can just select the number of stones. Okay, so uh, what we have to find that who will win the game. The scores of each player is the sum of the values of stones taken. Okay, and initially the score for both Bob and Alice will be 0, and the objective is to get the highest score. And yeah, I hope you got the question. Okay, if the score is for Bob and Alice is equal, then we will return tie. If Bob will win, we will return Bob as a string. If Alice will win, we will return Alice as a string. Okay, so let's take this example. We are given 1, 2, 3, 7. We are given the string. Okay, what will happen? What will happen if Alice will select a single one? Bob will always try to win the game. So Bob, what will do? Bob will what he can do is that he will take all these at a time. Then, because we can select three stones at a time, so at this time Alice score will be 1 and Bob's score will be 12. So we can say that surely Bob will win. Suppose if Alice is a bit smart, he takes two strings. Okay, he takes two. Okay, two stones at a time. Then also Alice score will be 3 and Bob's score will be 10. Suppose Alice will take 3, then also Alice score will be 6 and Bob's remain with 7, so Bob's score will be 7. The question is such that we can only take the stones from the starting. Okay, we can only take stones from the starting, not from the end. Okay, so in all the three cases, case 1, case 2 and case 3, if we will take 3 at a time, then 6, and so in all these three cases we can see that Bob is the winner in all the conditions. So we will return that Bob will win in this game. Okay, so let's try to generalize this question. Okay, how we can approach this question. What were the values? The values were 1, 2, 3, 7. Okay, now let's think. What? Let me change the color. This is the initial condition. Okay, so from this we can say that there are other conditions, like let's say that at first, okay, at first this is selected by Alice as a single element and rest is selected by Bob. Okay, so we can make a recursive call for this. Okay, let's see how. What I'm doing, I'm just extending it. What I'm doing, just 1 is taken by A and 2, 3, 7 is by other one. That is, this is Alice, this is Bob. Now what Other thing can happen is that uh, let me scroll down. Okay, let me remove all these things. I want to write it clearly because there are multiple conditions now. Let's explore all the conditions. Let me take the green color. We have the array 1, 2, 3, 7. Okay, this is what we have given. Let's say at first call Alice take 1 and Bob takes 2, 3, 7. This is Alice, this is Bob. Or what we can say, the other thing can happen. Alice may take 1, 2 and Bob may take 3, 7. Or what we can say, the third condition, that Alice will take 1, 2, 3 and Bob takes 7. Okay, these are the three initial steps that can happen. Later what we can say, that in this condition also we have a tree like this, as Alice has also taken 1. Later Bob may take only single element as 2 and rest is for Alice. Or what we can say, Alice already taken single element, that is 1 is, sorry, 1 is fixed for Alice now. So what we can say, that 1 is fixed for Alice. Now Bob is taking 2 elements. Sorry, why I am writing this. Yeah, Bob may take 2 elements, 2, 3, and then Alice again is taking 7. This may also happen. Or we can say the third thing, that okay, I think, yeah, 1, 2, 3. Okay, the first okay, these two are the only conditions. Now further for this, what can happen, that here 1 is taken by Alice, then 1 is taken by Alice, Bob has already taken 2, we can't change it. Then what can happen, Alice may take only a single element, that is 3, and then Bob may again take single element as 7. So this is the condition last. No other condition is possible, I guess. Okay, now here we can say that okay, this is also done because we have reached to the last one. So no. Now in this case what we can say, this is reserved, this part, for this part. This is already taken by Alice, 1 and 2. Now only 3 is taken by Bob. Only 3 is taken by Bob. And 7 again taken by Alice. This can also happen. So what I want to say in short, that there are multiple things that can happen. What we have to return is, we have to return the maximum. Okay, so the basic approach, this is just what I want to show you somewhat, tree how it will grow. Now what I want to say, instead of calculating the score of A, that is Alice and Bob, what we can say, we want Alice to win. Okay, because Alice is starting the game, Alice will start. What we can say, that if Alice score minus Bob's score is greater than 0, then we will return Alice. Otherwise, if Alice score is equals to Bob's score, then we will return tie. And if Alice score minus Bob's score is less than 0, then we will return Bob. So these are the three things that we have to do. Instead of calculating the score of A and score of B, what we can say, we can directly use this and we can store as a single entity in a DP array. Okay, so for that, and in the question we can select three consecutive numbers, three consecutive piles of stones at the same time. Okay. So what we will do is we will also maintain a sum of we can say the sum of one element plus sum of two element for sum of three element. We will check all these three cases. What we will check? We will check for all these three cases. Okay, and we will return the case in which we will get the maximum score so that Alice can win the game. Okay, otherwise Bob will win the game. Now how we'll write the code is like, we will maintain a DP array of size n plus 1, we can say. Let's say I'm just taking 1, 2, 3, 7, this was the array. What we will do is I'm just making another DP array. What we will do, we will assign all values as 0, 0, 0 initially, and we will try to calculate if he selects 1, he will have to face this. Okay, so the score will get, this Alice score is 1 minus Bob score is this 12, that is minus 11. If he selects like 2 at a time, I'm not showing all the test cases, but I'm just showing few only. So if he selects 1 and 2, so total score, Alice score will be what, 3, and it's 10. Then we will subtract, we will get minus 7. And if it selects all these 1, 2, 3, total score will be 6, and Bob's score will be 7. At this condition we will get minus 1. We have to take maximum of these three, max of minus 11, minus 7, minus 1, that will be equals to minus 1, and we are getting maximum as minus 1, so we will return that the net score is negative, so we will return Bob will win the game. Okay, so this is how we will try to do it. Okay, let's try to code it out using DP. Okay, how we will do it? Okay, so what I will just write n, that is the length of the stone value array. What else, what I want is I have to create a DP vector, and the size of this will be initialized by 0. Now what I will just try to do, I will start from the last and I will iterate over this stone values. What I will do, I will mark the first value as 0 because it is 0. Initialize, I will have to take a max now, so I will initialize the value of dp of I equals to min. Thereafter I will initialize, because we can take 3 at a time, so yeah, I will also store a sum so that I can if I take a single element, if I take 2 elements, I will add in the sum. If I take 3 elements, I will add in the sum, and I will try to calculate using that only. I will just write I will iterate from j equals to I, and now I will iterate till I plus 3 because we can take 3 elements. Okay, and thereafter I will just add the stone value, number of stone value in the sum, and I will check that dp of I will be equals to maximum of dp of I and sum, and I will sum will be equals to Alice score. Okay, this is Alice score, and I have to subtract the Bob score. So what I will do, I will okay, this is not yeah, we can say Alice score, and what we were storing, we will storing difference of Alice score minus Bob score. Okay, so I am just subtracting the Bob score that may be there, that will be dp of j plus 1. Okay, now I think it is correct. Now what we will do, if dp of 0, because we have iterated from the last and we will get our answer in the first element, then we will return that if it is greater than 0, then we will return Alice. Otherwise, if dp of 0 is less than 0, then we will return what? Bob. Otherwise, we will return ties. Okay, ties or tie. Okay, so this is how we will do the code of this. Let's try to run it this. Okay, we may get error because we are getting out of point, so we have to put, because when we are doing I plus 1, it may get out of bound, so it should be minimum of n and I plus 3. So let's try to run it again. So you can see it is almost accepted, but still there is a small error. Let's try to find it out where we have done a mistake. Okay, let's try to see. Okay, why I have written I here? It should be J. Yeah. So here we can see that it is working fine. Now we will submit this question, and you can say that it is submitted successfully. So thank you for this video.